So the first thing, I listed out a sequence of things that should be answered. And ultimately, this sequence of things is not in any particular order. This was me looking at it being like, yeah, you need to know this, you need to know this, you need to know this, you need to know this. Okay? So let's go through and tackle this from kind of a proper sequence, I guess. What are we being asked to solve?
Percent yield of magnesium chloride.
Okay, the percent yield. How do I calculate a percent yield? All right, theoretical. Okay. What are the units on my percent yield? Nothing. So no units. Yeah. Which means, what do the units have to be on my actual and theoretical? There's two options. One, they don't have units. Does it make sense to not have a unit on a number?
No.
Not really. So the actual and the theoretical will have a unit. What do those units have to be? The same. Okay? Do I know anything about either the actual or the theoretical? We are told in the question what the actual yield is. It says at the end of the reaction, a chemist recorded that mass. So at the end, I have a product, 60 grams of magnesium chloride. Here's the first case where we could potentially enter something that we need to identify. Is that a proper formula? No. Magnesium's a +2, chloride's a -1. That needs to be MgCl2. This needs to be divided by our theoretical yield. And because we said our percent has to be unitless, that means the units on my theoretical yield need to be grams of magnesium chloride. Right? Our theoretical could be called calculated, because what we have to do is take what we started with and convert those or calculate those into a theoretical maximum that we would end with. Right? So I would go back to the rest of the question and be like, well, what did I start with? Okay? I started with two different pieces of information. I hate boxing things this way, but I'm doing it anyway. Okay? Do it in colors. What does that mean? I started with two things, which means I'm going to have to see how those two things interact with each other to make magnesium chloride. Okay? I'm going to have to convert magnesium hydroxide into magnesium chloride. I'm going to have to convert hydrochloric acid into magnesium chloride. Right? So how would I do that? Well, what do I want? Magnesium chloride, what am I starting with? Magnesium hydroxide. Is that a proper formula? No. How much magnesium hydroxide? 50.6 grams. I need to do that conversion, okay, or find that relationship. Are those units the same? No. What is different about those units?
The substance.
The substance. Chemistry. Where do I find a substance conversion?
Balanced chemical equation.
From a balanced chemical equation. Where's the chemical equation? I now know I have to write one. Okay? What we're slowly doing is slowly kind of piecing that information in to go through and solve. I need a percent yield, but I don't have a theoretical. Okay, well, what do I know needs to be that theoretical? I know it needs to be units of grams of magnesium chloride. I know that theoretical yield comes from what I started with. Well, crap, now I've got a substance conversion. How do I do that substance conversion? I need a chemical equation. I'm not given a chemical equation. So what do? I create a chemical equation. Okay, that chemical equation has to be balanced. To have it balanced, I have to have predicted the products appropriately. To be able to predict the products appropriately, what do I also have to be able to do? What kind of chemical equation it was, so that I can properly predict the products. Then I can balance the chemical equation. Then I've got a substance conversion that I could potentially bring into this one sol. Okay? I just talked through a lot of that and didn't write any of it down. How many of you wrote any of those questions down? You solve this by answering those questions. If you aren't asking yourself those questions, no one else will. Okay? Which means what happens on the exam? You can't answer any questions. Okay? So there's now a lot more information up here. Percent yield, I just tried to re-show that in blue because I shifted stuff around. Here's the purple for our conclusion on that. I'm going to borrow somebody's work and show their calculation or use their chemical equation. I went through and did it for the magnesium chloride or for the HCl. I wanted magnesium chloride. There's the HCl. What unit conversions would I have to go through and do? Notice within those unit conversions, I haven't dropped in any numbers. Okay? And that's important. You shouldn't be dropping in numbers because that's what ends up happening is people just start saying, well, I'm going to do this. Well, what you're going to do was wrong because you're missing that unit piece. Okay? So I'm going to sort of rip on the work here that a student put together and sort of kind of acknowledge that they did a really good job. They internalized so much information correctly that it becomes difficult for other people that don't understand what they did to be able to process. Okay? And that's where it can become challenging for students finding help. Okay? So if we go through and take a look at this, in purple, red, blue, and then we're both using the same chemical equation, we've got the roots for all the same calculations. Okay? So if we take a look at their HCl path, their HCl path is right here. Okay, Jiminy. Yeah, that's a bit of a jump, but I know what you did. So when we look at this, it says 45 grams. Grams of what?
HCl.
Okay, why do you say HCl?
That's your path of HCl.
Okay, you could see they're writing it underneath the HCl. So they are including the unit in that calculation. They're including it in a category, which is what's allowing them to keep it there. So we're both starting with the same thing, 45 grams of HCl. What did they decide to convert to?
Magnesium chloride.
Moles of what?
Chloric acid.
Right.
Okay. Without that information there, do we know what they were converting to? Okay. That's where it can be kind of questionable. Okay. So you looking at somebody else's work may be like, well, I don't understand what they did. Okay. But I see that number. How did they get that number? Well, they must have just done this. So I'm going to repeat that calculation. That is insanely problematic because what you're doing is trying to reverse engineer what somebody else did instead of trying to understand the process behind what happened. What was their process in going from grams to moles? Okay, if they were going grams to moles, why would they have gone grams to moles for HCl? So if we make the assumption that this is HCl and this was moles of HCl, why would they do that? To cancel out something. Okay. Okay. They're recognizing that at some stage through this process, they need to get into magnesium chloride. And so what they've done is internalize that calculation. Okay? That conversion needs to happen, and they know that conversion in the process of needing to happen needs to be in moles. So their first step is to go through and do what? Convert it to moles. Okay? That is a perfectly legitimate attempt to going through and doing this. Okay? The reason why I balk at that statement is that that's pretty much just saying, I knew that I needed to do this, so I did this. Why don't you just go through and say, I know I need to do this. There's my conversion. I want to convert moles of magnesium HCl into moles of magnesium chloride. I'm writing the work now. That information is identified for me. Okay? The reason why people don't like to show that calculation right away. What happened to the units if we just look at that first conversion of mine in red? None of the units cancel. Okay? So we may not like that because it doesn't look as pretty. Okay? Don't judge a book by its cover. Okay? Do we acknowledge that that information is important and it needs to happen? Yes. I'm calling that information out ahead of time because I want to keep hold of that. Okay? And why do I want students to keep hold of that and put it down now? Because if they wait 30 seconds to do a different conversion, what happens to that information? It disappears. And you lose it, and you end up not being able to get the conversion back or to remember that you need to do that. For some people, like the person that did this solve, fantastic, they didn't lose it. Okay? What will eventually happen is they will lose it, and then it's going to suck. Okay? So there are other ways to organize and logic through this. The process that I'm trying to establish for you is one that always works, regardless of the solve. Their work and setup here, does this work to transfer inches into centimeters? Or inches into millimeters? It's a different solving process. So they have to learn multiple processes. If we go back to looking at the purple one, because we're done at 15, right? Man, I don't know about you, but time sure moved to me. Let's take a look at that purple conversion. What do I want? Magnesium chloride. Is that the same thing as magnesium hydroxide? No. So what I'm going to immediately go through and do is acknowledge that in that conversion, my substance changes. I want magnesium chloride. I want it in the numerator because that's where it's going to end with. Magnesium hydroxide, I want in the denominator. I can now acknowledge that this is a substance conversion. Where do I find substance conversions? In a balanced chemical equation. I can now write a balanced chemical equation that allows me to see that relationship. I'm using the information as I need it, not saying, I know I'm going to need all this information. Why would I know I need that information? Because I'm an effing genius. Okay? The only reason you're an effing genius is because you've done it a billion times. Okay? If you haven't done it that many times, you need a different process. Use the information as you need it. Okay? In a conversion or a chemical equation, what are the measurement units? They can be moles or molecules or atoms. In this case, moles makes the most sense instead of molecules because? Not because we're working with moles. We're looking at an actual lab environment where we're taking decent size masses to deal with a single molecule. We wouldn't be able to get a mass at that scale. Moles makes the most sense because it scales everything up. That's why we use chemical equations as moles. The numbers I can pull from my chemical conversion, my balanced equation, which I think was done correctly, 1 and 1. What happens? My units don't cancel. I now have a branch point because I can do two things. I can say magnesium chloride, grams of magnesium chloride. I want that. I don't have that. Or I can say I don't want the magnesium hydroxide. Class vote, fast. No magnesium hydroxide. So the magnesium hydroxide I want to get rid of. Okay, moles of magnesium hydroxide. I am also looking back through this and saying I also don't want grams of magnesium hydroxide. Is that a conversion factor that exists? Yes, that conversion factor is found in the periodic table, which would be 36.45. Nope, that was the wrong thing. Thank you. 58.33 grams is 1 mole. Cool. This now helps simplify things. What's my next tackle? I want grams of magnesium chloride. What do I not want? Moles of magnesium chloride. What did I want? Magnesium chloride. What do I have? Moles of magnesium chloride. Where's that conversion factor found? Also on the periodic table. Different number. That was the 95.21 grams mole. Does anybody see 95.21 show up in the work here? 58.33? No. So they did a phenomenal job holding that information. And to that end, and their credit, in a straight-up multiple choice, they've shortcutted the system and they can now get an answer faster than if we showed work. Cool. They've also increased the odds of making a mistake and potentially getting a faster wrong answer. Okay? They get it right. All I can be like is, yeah, okay, cool, sweet, dude. Okay? What we should now be able to do is run the calculations both in the mixed colors where we showed those unit systems and in the ones where I didn't do in numbers. Okay? In those numbers, we're going to find that we're going to get 2 different answers. Okay? If we assume magnesium hydroxide is our limiting, our grams of magnesium chloride comes out to be, did you give me a number? Oh, you converted it to moles. Dang it, who kept it in grams? 58.8. Not for the magnesium hydroxide. That was for the HCl, wasn't it? 82.6 grams of magnesium chloride in purple. And if we assumed HCl was our limiting reagent, was 58.8 grams. Which is our limiting reagent? HCl, which means this 58.8 is my limiting reagent, which means that number is my theoretical yield. I can now dump that all the way back up in blue, that tiny little flitty thing up there, and we do 60 divided by 58.8, and we get a number that is over 100%. Number one response from students is, I screwed it up. I must do it the other way. Instead of it being 60 over 58, it should be 60 over 82. They get the answer wrong. I must have done it wrong. I must have switched those two, actual and theoretical. It should be 58.8 over 60. Okay? You have to trust the process because all of those permutations show up. Okay? Unfortunately, we are out of time. I apologize for keeping you late. We'll come back and look at this question on Thursday with what would exam questions be out of this.